Do you know of any specific problems associated with using organic solvents in making standards or as your diluent for your samples? I'm not sure you are talking about purely organic mix, or you are talking about a combination of organic as well as aqueous mix. I'm not sure on that. If you could little bit explain that, I would be able to see if I can answer that question. There is another question from a customer here. I would like to know about what the maximum lifetime for mercury about 100 ppb. Mercury as such is not only for storage problem, sometimes it has analytical problem too. 100 ppb, about 0.1 ppm. It's we have tested it, and in a proper selection of matrix, we were able to preserve it for 6 months. But beyond that, it's very hard. And as I have said, the selection of matrix is very important for mercury standards. What is the question here is, what is the reason for the great difference between cleaning by machine or manual? As I said, manual cleaning is prone to, the word I can think of right now is boredom. You may say to your technician, rinse 6 times, but do you know really if the technician did it 6 times? Whereas in a pipette washer, the way it, unfortunately I don't have a video, you can log on to our website and you would see a demonstration of that pipette washer. The way the water comes into the pipette through the tips, it gushes out. When it gushes out like that for 15 minutes, all the impurities from inside as outside get washed away. What is the best way to clean plasticware in order to remove possible contaminants? To clean plasticware to remove possible contaminants. So in our lab, before when we do digest certain samples in Teflon, before we use that, we boil some nitric acid. Of course, under the hood, taking all the proper precautions, we fume nitric acid a couple of times, and then sometimes if the sample that is to be used can tolerate hydrochloric acid, we do aqua regia as well. And then we rinse it thoroughly with double DI water before introducing our sample. The question here is, how do you determine, set as a manufacturer, expiration date of an inorganic, say 100 ppm lead standard? We all know the chemistry behind each of the elements that we make. That's one of the reasons. The second way we do is we have data over a period of time. We were making these standards for the past 45 years plus. So we have collected data over a period of time, and this data will be reviewed, and based on that, we set the expiration date and time. Do the stocking temperature affect the stability of the standards? The question is, stocking temperature, can it affect the stability of standards? As long as you store your solution in ambient conditions, it's okay, not a problem. During the millennium change 2000, we did study storing the solutions at 4 degrees and below, because we were worried whether there will be a power interruption for quite a number of days. We found, after analysis of those solutions, we found that absolutely nothing happened. As long as we thaw it back to the room temperature and we analyzed it, we were okay. There was no problem at all. So storing at a low temperature is not a problem. But if you increase the temperature to greater than 35 degrees Celsius, what happens is there could be transpiration loss, which could be enhanced because of the higher temperature. Then the solution may not be giving you the correct reading. What can beryllium contamination come from? Yes, this is a good question. So when I was preparing the slide, I did see a beryllium contamination in one of the plastic bottles. We were wondering whether it was coming from any of the plasticizers they use. Though a plastic manufacturer does not put beryllium as such, they use cadmium, antimony, and lead. They do not use beryllium, but it could have been a contaminant in one of them. Perhaps because of that, we did see some beryllium in that.
Okay, that seems to be all the questions that we have. There are a couple asking about odor eroters, the part numbers. Actually, I was going to let everybody know that everybody who attended today will be receiving a complimentary sample of odor eroters. So we'll send it to you along with some more information. But if there's any other questions, then feel free to type them in the chat box right now. Doesn't look like we have any. You're welcome, John. Okay, so looks like there's no more questions. So I'd like to thank Vanuja once again for giving a very informative presentation. As a reminder, we will be sending everybody a copy of the presentation slides, and a recording of the webinar will be posted on our website next week. We'll let everybody know when that's posted so you can go ahead and view it. And again, everybody who registered today will also be receiving a free sample of odor eroters. And you will also receive an email invitation to participate in a short survey so we can get your feedback on today's webinar. Everybody who completes the survey will receive a 10% discount off any order of $100 or more. Anyone interested in any of our previous webinars, the BPA and phthalates in water or the chemical gourmet, can see on-demand versions of them right now on our website at speccsfp.com. And I would like to thank everyone for attending today, and we hope that you walked away with some useful tips and information on minimizing contamination in your lab. We appreciate your time, and we look forward to seeing you again in a future webinar. Thank you.